So now we are shifting to the next part of the power screw. First I will take the highlighter. For self requirement for the lowering and raising the load, now we are going to see how we are going to design a what is self-locking screws. Now the name itself can explain you that self-locking means how we can lock ourselves. So here the angle is there, friction angle and the helix angle, both are very important angle. So if we seen that phi is less than alpha, then what happened? The torque required to lower the load is negative, and this condition is not required. It indicates that a condition that no force is required to lower the load, and this condition is not required actually. So this is what the overhauling of the screw, this is known as overhauling. So in some condition it is needed, but it is not required in the power screw. So this is known as the overhauling of the screw. That means by a single effort the nut will get open. Now this is also called a back driving of screw. So this property, as I told you, that it's not applicable in screw jack because the load will get lower or the vehicle will get lower down easily, but it is used in Yankee screwdriver. You can google it about it, you can find what is Yankee driver, or you can find an animation also in your YouTube. Yankee screwdriver uses such types of overhauling screws. So in this type of screwdriver there is a high lead thread on the barrel and its handle is a nut. So the worker pushes the handle axle down, the barrel turns and drives the wood screw into the place. You will see the animation also. Now when phi is greater than or equal to alpha, a positive torque is required to lower the load. Under this condition, the load will not turn the screw and will not descend on its own unless an effort P is applied. So this is known as the self-locking screw. That means until and unless you are not going to give an effort, the load will not raise or lower itself. So this is very useful properties, the screw jack application. So for this, the main thing is what? A screw will be self-locking if the coefficient of friction is equal to or greater than what the helix angle. For a self-locking screw, it should be greater. So phi should be greater than alpha, then only this condition can be known as the self-locking screw. So tan of phi is greater than tan of alpha. So mu is equal to what? L upon pi dm. So L is the lead upon pi dm. So this is the formula. Now the some conclusion which are drawn based on this examination is that the self-locking of screw is not possible when the coefficient of friction mu is low. So the coefficient of friction in the surface of the screw and nut is reduced by lubrication. Okay. So excessive lubrication may cause the load to descend on its own. That's why coefficient of friction should be important here. And self-locking property of the screw is lost when the lead is large. So lead increase with number of starts. So for a double start thread, the lead is twice of the pitch for a triple thread. So I think you understand this.